Question 13. Isosceles triangle with x both sides and x plus 1 as the hypotenuse, so we use Pythagoras. X squared plus x squared must equal x plus 1 all squared. So we get 2x squared equals x squared plus 2x plus 1. Bring everything over one side, take away an x squared from both sides. Take away 2x from both sides and take away 1 from both sides, which is part 1, which was required. Now part 2, find the length of the hypotenuse. So this is a quadratic that can't be factorised, so we're going to either complete the square or quadratic formula. So let's use the quadratic formula. Negative b, so 2 plus or minus 2 squared, which is 4 minus 4, 1, and negative 1, all over 2a, so 2 ones, which is 2. We get 2 plus or minus 4 plus 4 is 8, which gets you 2 plus or minus 2 root 2 over 2. The 2's can all cancel, the 2 wholes can all cancel. 2 goes into 2 once and into 2 once. Now 1 plus root 2 will get you a positive answer, 1 minus root 2 will get you a negative answer for x, and you can't have a negative length, so x is actually just going to be 1 plus root 2. Now, so therefore, if x is 1 plus root 2, the hypotenuse is x plus 1, so which is 1 plus 1, which gets you 2 plus root 2. Okay, b. The sum of the roots is negative b over a, which is negative 4 over 2, which gets you negative 2. The product is c over a, which gets you negative 1 over 2. Okay, now this expression here, alpha squared plus beta squared, the only way we can get that is to square this one. But when you expand that, you'll get alpha squared plus 2 alpha beta plus beta squared. We don't have 2 alpha beta there, so we actually need to balance the equation by subtracting a 2 alpha beta. So therefore, alpha plus beta all squared. Alpha plus beta is negative 2 from the previous question. We'll square that. And 2 times alpha beta, which is negative a half. So we get 4. Half of 2 is 1, negative and negative is a positive, so we get 5. So we have a linear line and then a quadratic. So in the linear, let's rearrange. Y equals negative x minus 1, which means we have a y-intercept of negative 1 and a gradient of 1, negative 1, which means basically that. So negative 1, and if it's got a gradient of 1, it's going to be negative 1 there also. Now the quadratic is a concave down quadratic with a y-intercept of positive 1. So that is going to look like this. Now, this will be positive 1, where the parabola meets the x-axis. Now, using the inequalities, we need to go greater than 0 for the first one. Now you can either test, so if you test 0, 0, you put 0, 0 there, you get 1 is greater than 0. That's true. So therefore the line is above the axis, but just hold back on that one. Now this one, the equation is less than, so it's actually below the curve, but you can again test 0, 0, and you get 0 is less than 1, which is true. So therefore that is under the curve. So where do they both intersect is between. Now D. Find the coordinates of the point where the tangent is parallel to that. So if it's parallel, our gradient of y equals 2x is obviously 2, so it needs to, this one needs to have the same gradient to be parallel. So to find gradient, we can differentiate. So times by the power, reduce the power by 1, and you get 4. Now this has to equal a gradient of 2. So we get 3x squared over 2, add 4 to both sides, we get 6. Take times by 2 both sides, we get 3x squared equals 12. Divide by 3, we get x equals, squared equals 4. Square root, we get positive and negative 2. Now we need the coordinates, so we need to sub both of those in to the original function y to get the coordinates. So when x is positive 2, we sub that in to here, we get 8 over 2, which is 4, minus 4 2s are 8. So at positive 2, we get an answer of negative 4. And at negative 2, sum that in, we get negative 8 over 2, which is negative 4, minus 4 times negative 2, which is positive 8. Negative 4 plus 8 is 4. Alright, in the diagram, D is produced such that BD bisects ABC. So therefore, this angle equals this angle. E is produced such that CE is parallel to DB. Alright, show that BE is equal to BC. So we need to show that this line here is equal to that line there. Alright, so we have angle ABD equals angle DBC was given to us because it was bisected. Angle ABD equals angle BEC because they're corresponding angles, because DB is parallel to CE. Also, DBC is equal to angle BCE because we have alternate angles because DB is parallel to CE. Let's mark those on. So obviously that is my Z angle there, and this is my F angle. Now we know that BCE is equal to BEC, and therefore BC is equal to BE because sides opposite equal base angles are equal. So what it's saying is we have an isosceles triangle with that angle and that angle equal, therefore those two sides must be equal.